Today we are going to talk about this chemical reaction and particularly exothermic reaction, endothermic reaction, reversible reaction and irreversible reaction. Now let's start with exothermic reaction. The first one, what I told you just now, exothermic. Exothermic reaction. What is it? Exothermic reaction. A chemical reaction in which heat energy evolves, produces, is called exothermic reaction. It means the key word is heat energy evolves. This is a reaction in which heat energy evolves. Now we can take some example. Just for example, when carbon bonds in air, it bonds. Bonding means what? It reacts with oxygen. When carbon bonds in oxygen or in air, then what happens? Carbon combines with oxygen to form what? Carbon dioxide. And we know that when carbon is bonding, it produces a lot of heat energy, and we can write heat energy. If we are told to write an equation, what happens when carbon bonds in air, then we can say that when carbon bonds in air, it reacts with atmospheric oxygen to form carbon dioxide. This part is not needed. But if you are told to write about exothermic reaction, then you can define and you can write here plus heat energy also, because this is the reaction in which heat energy evolves. This is the example of exothermic reaction. Now next is when a beaker is taken and a little amount of hydrochloric acid is taken, and if a piece of zinc is dropped into it, then what is seen? This zinc piece reacts with hydrochloric acid and the beaker becomes hot. If we hold this beaker in our hand, we can feel that previously it was not hot, but when reaction starts, then continuously it becomes hotter and a little more hotter till the reaction takes place. That's why this reaction is exothermic reaction, because heat energy is produced. We can write this way: when zinc reacts with hydrochloric acid, then what happens? This is displacement reaction, single displacement. Zinc displaces hydrogen. That's why ZnCl, zinc valence U2, that's why it is given to chlorine. Chlorine 1 not given to zinc. Plus the displaced hydrogen when becomes 3, this is diatomic. And heat energy also produces heat energy. This way it takes place. Now balancing, hydrogen 2, if we take here 2, okay, chlorine 2, chlorine balance, zinc balance. This is another what? Exothermic reaction. Now let's talk about one more. When hydrogen bonds in oxygen or in air, hydrogen when bonds, then what happens? It reacts with oxygen while burning. And what it produces? Water. It produces water. And in this reaction, certainly huge amount of heat energy produces heat energy. We can take this as exothermic reaction, and we can balance like this: oxygen 1, oxygen 2. If we take here 2, oxygen here 2, here also 2, 2 2 are 4, hydrogen 2. This way, these are few examples of what? Exothermic reaction. Now this is finished. Now let's talk about endothermic reaction. What is endothermic reaction? Endothermic reaction, what is it? This is just opposite of the exothermic reaction. We can say this way: a chemical reaction in which heat energy is absorbed is called endothermic reaction. Here keywords are heat energy absorbed. Heat energy is absorbed. This is what an endothermic reaction. What are the example of this endothermic reaction? Just for example, while lightning, nitrogen of atmosphere combines with oxygen, and this combination reaction requires huge amount of heat energy that is provided by this lightning, and plus heat energy. And this reaction this NO means nitric oxide forms, and it requires a lot of heat energy, and this is endothermic reaction because heat energy is absorbed, and so endothermic. Oxygen 1, oxygen 2, that's why if we take here 2, okay, nitrogen 2, nitrogen 2, this is the one of the example of endothermic. Now next, let's talk about another also. When sodium chloride is heated to very high temperature, it requires heat energy. Heat energy to decompose into sodium and chlorine gas. Chlorine when becomes free, it is diatomic, that's why Cl2. Okay, chlorine 2, chlorine 1, if we take here 2, okay, sodium also we have to take here 2. This requires heat energy, and this is one of the endothermic reaction. Now next, when carbon reacts with hydrogen, it takes heat energy. Carbon reacts with hydrogen, then it takes heat energy, absorbs heat energy, and forms what? Acetylene, C2S2. This is called acetylene. Hydrogen 2, hydrogen 2, carbon 2, carbon 2. This way, this is one of the another example. And when carbon reacts with sulfur, it also absorbs heat energy and forms carbon disulfide. This carbon, actually it happens this way. Carbon, sulfur when combines, valency of carbon is 4. It should be given to sulfur. Sulfur 2 should be given to carbon. And here 2, here 4, if we take common, CS2. This is carbon disulfide. And here if we take 2, then this reaction is balanced. These are the reaction in which heat energy is absorbed, and we can give them as endothermic reaction. Now let's talk about another reversible reaction. Now third one, reversible reaction. What is it? Reversible reaction. The word says, what is it? Actually, the chemical reaction in which products can recombine with each other, or maybe only one product, or dissociate to get back the reactant or reactants, then the reaction is called reversible reaction. Whether the product recombine, or if only one product, then dissociate to get back the reactant, then that type of reaction is called what? Reversible reaction. Just for example, when nitrogen combines with hydrogen, this is a reversible reaction. We'll give symbol like this. Arrow is given in both the sides. It may take place towards this direction. Nitrogen when combines with hydrogen, then ammonia forms. Ammonia, hydrogen 3, hydrogen 2. If we take here 2, 3 2 just 6. Then if we take here 3, then balanced nitrogen 2, nitrogen 2. This is reversible reaction. That's why in place of giving arrow mark to one direction, I have given arrow mark to both the directions, because when they combine, they form this, and again ammonia can dissociate to get back to the same reactant, and that's why this is reversible reaction. Now next is, let's talk about irreversible. Irreversible reaction, just opposite of the reversible reaction. We can define this way: the chemical reaction in which products cannot recombine, or products doesn't dissociate to give back the reactant. Doesn't recombine or doesn't dissociate to give back the reactant is called irreversible reaction. Just for example, zinc when reacts with hydrochloric acid, we have done this just before. So look at this. This is zinc when combines with hydrochloric acid, then what happens? They form what? Zinc chloride, zinc chloride. zinc balance E2 plus hydrogen. We can balance hydrogen to here to chlorine to zinc. This reaction takes in one of the side. This product never recombine to form zinc and hydrochloric acid. That's why this is one of the example of what? Irreversible reaction. This way, what I told you today, this exothermic reaction, endothermic reaction, reversible reaction, and irreversible reaction. We'll talk about rate of reaction in another class. This much for today.